Hey everyone, today we're going to talk about electrical measurements, including amps, volts, and so on. If you're like me, you're finding it hard to understand all the electrical measurements of EVs. The main measurements I've seen are kilowatt hours, volts, amps, and kilowatts. As we talk more and more about EVs, these measurements are becoming much more important to me, and I want to understand better how they all relate back to not only EVs, but how I can make them similar in my head and related back to gas cars. Bear with me here a little bit as I'm trying to explain the concept or the ideas of these measurements between gas and electric cars, not necessarily the scientific measurement equivalent, if that makes sense. If you just want to see the summary at the end, skip to the 6 minute and 20 seconds mark. I've seen several videos and pages describing this, which have helped, but I've had to think hard to understand how these numbers relate back to electric cars. For example, some EVs like the Kia EV6, the Hyundai Ioniq 5, Hummer, Porsche Taycan, they all have 800 volt system while others have only 400 volt systems. What does this even mean? Well, here's how I think about it in my head, so maybe this will help you too. First, let's talk about modern internal combustion engines for a minute. They run on gas or diesel for the most part, and for the engine to work, it needs this fuel delivered into it. They rely on a fueling system that runs from the tank that pumps the fuel lines full of fuel into a high pressure pipe called the fuel rail, which is usually sitting on top of the engine. From the pressurized fuel rail, the gas or diesel will flow through injectors as they open and close depending on when the engine needs it. Let's get into a bit more detail, starting back at the beginning. The fuel tank, as you all know, holds a certain amount of gas or diesel, which we measure in gallons or liters, depending on where you're from. From there, as gas travels into the fuel rail, it's pressurized so that it can instantly travel through an opened injector when the engine needs it. It's there on demand, and the higher the pressure, the faster that injector delivers that fuel. Some of these fuel rails, especially in high performance diesel applications, run at very high pressures. That's important for later. We measure any fuel rail pressure usually in pounds per square inch or kilo pascals. The more pressure and the greater the opening in an injector means greater flow rate of fuel. You may have heard of upgraded fuel injectors, right? They usually allow a higher flow of fuel compared to normal injectors. The higher the fuel flow, the more fuel is entering the engine per second, and therefore, the more fuel can be consumed by the engine. This flow of fuel is measured in gallons per hour or liters per hour and contributes to how much power you generate in that engine. All right, here's the last part about gas cars before we get into EVs. The precise amount of fuel that is under all that pressure enters the engine through the injector in order to generate a certain amount of power. That power is specified by the driver based on where their foot is on the accelerator. This power is measured in the car enthusiast's favorite units, horsepower. Or if you're from some other places, horsepower is instead measured as kilowatts. To keep things simple, just think of the fuel going into the engine as a direct contributor to how much power will be generated by the engine. More fuel, more power, and therefore a bigger horsepower result or a bigger kilowatt result. So, still with me? Now that we've talked about the gas engine and how that works with these measurements, I'll now explain how electricity can be measured in somewhat the same way. Let's go back to our gas tank in the ICE car. A gas tank in this car is like the battery in an EV. This is pretty simple to understand, but you may have seen batteries measured in kilowatt hours. Well, this is how we measure energy capacity in batteries. We use kilowatt hours. This is similar to how we measure gallons or liters of gas in a tank. Don't worry about the difference between kilowatt hours and kilowatts for now. We'll talk about that later. Just know for now that the battery capacity is measured in kilowatt hours, similar to how we measure gallons of gas in a tank. So for this measurement, think about kilowatt hours in a battery as equivalent to gallons of gas in your gas tank. All right, we've talked about kilowatt hours. Next, let's talk about what a volt is. Remember when we talked about higher pressure in a fuel rail that can get the gas to the engine quicker? Well, volts is how we measure electrical pressure. The more volts you have, the more aggressively the electrical energy moves to the motor and the stronger it can turn the motor. High performance cars like the Porsche Taycan use a high voltage pressure to not only get the most propulsion out of their electric motors, but also to do so efficiently, not unlike the precision and efficiency offered by a high pressure fuel rail, although that comparison is not perfect. So while we measure fuel pressure in pounds per square inch or kilopascals, We measure electrical pressure in volts. Okay, moving on to amps. As you know, injectors let in a certain amount of fuel when they open. That's measured by gallons per hour or liters per hour. Here's how you can think about it. The more amps a car can provide to its electric motor, the more power that motor can produce. This is just like gas cars. The more gas you can provide to the engine and air also produces more power. So amps are somewhat comparable to gallons per hour of fuel. Which brings us lastly to kilowatts. Kilowatts is how we measure horsepower in an EV. In our gas car example, the horsepower was affected by the fuel flow, and in our EV, the kilowatts of power is affected by the amps. You see how they're kind of related? Also, remember back when we talked about kilowatts of fuel in the battery versus kilowatts of power the motor is generating? Well, conveniently, a kilowatt hour in a battery is just how much power the battery can supply in 1 hour at a continuous rate. So think about an example Tesla with 77 kilowatt hours in the battery. With that 77 kilowatt hours, that Tesla can supply the motor with 77 kilowatts worth of electrical power for 1 hour continuously. All right, that was a ton of information. Let me see if I can summarize a little bit with this one table now that we've completed it. Looking at this table, you can see all the equivalent measurements on the left and the right between gas and electric cars. If you just want to watch this one part, this is the part to watch. You can see that both gas vehicles and electric vehicles have very similar measurements, just different ways to measure them. On the left-hand side, you can see there's the amount of battery or tank capacity that you have in the vehicle, the storage, if you will. You can have a fuel pressure or an equivalent electrical pressure. There's the fuel flow or energy flow. And then lastly, there's the amount of power. Both types of vehicles measure these things just in different ways, and this table describes the equivalency between these two, or at least how I imagine the equivalency. I hope this helps a little bit, and let me know what you think in the comment section. Thanks for watching the Mind of Matter YouTube channel, and catch you again soon.